Hello everybody and welcome back. Let's talk about the problem seats. There's a row of empty seats and filled seats represented by a dot and an X respectively. The goal of this problem is to find the minimum number of moves required to make the people sit together. The constraints mention that n, the total number of seats including both empty and filled, are between 1 and 10 to the power 6. So if we look on the right hand side, the input looks like dot dot x dot dot x dot. And the output of this question is 2. Now let's go ahead and take a look at a visual explanation to understand this better. So we have two people sitting on the indices 2 and 5, and the rest of the seats are empty. Now what can we do to get to a solution? Well, the question asks us to group these people together. So what we can do is we can ask the person sitting at the index 5 to move to the index 3. That way we'll have grouped together all of the people and we'll get a total cost of 2. Why is that? That is because the person was sitting at the index 5. So 5 minus 3 gives us 2. Basically, we're looking at the absolute difference between these two seats. Alright, so 2 is one possible answer and this is one possible configuration. If we go back to the original, now we can ask the question, hey, is there any other better thing that we can do? What if we ask the person sitting at the index 2 to move at the index 4? Well, we'll get the same answer as 2 because 2 minus 4 in the absolute difference of 2 and 4 is still 2. And of course, this condition is still satisfied that these people are grouped together at the end. So this is a pretty simple test case and there's not a lot of things going on. So what we'll do is to get a better insight into the problem, to get a better observation and analysis of the problem, let's go and take a look at a bigger test case. And I know this might look scary, but as we work through it, this will make a lot of sense. Alright, so the goal of this problem is to group all of these people together. So how about this? How about I go ahead and assume that all of these people are going to be grouped together starting from the index 0. So here's what we'll do. We'll ask the person sitting at the index 1 to move to the index 0. This will get a cost of 1. Then we'll ask the person sitting at the index 4 to move to the index 1 so that we can group them together. Then we'll ask the person at 7 to move at 2 and 8 to move at 3. In this way, we have grouped together all of the people and we have gotten the answer as 14. However, there is no guarantee that this is in fact the optimal solution. So what can we do to find an optimal solution? If you notice, the goal of this problem was to group together the people. In other words, we're looking at a contiguous segment of people that start from a particular index. In this case, these group of contiguous people started from the index 0. Maybe that is not where we have to start. Maybe the best, most optimal solution starts from the index 1 instead. And so this is what can happen. Basically, we are going to recalculate the cost of moving every single person to their appropriate seats. Right, so 1 moves to index 1, 4 to 2, 7 to 3, and 8 to 4. Make sense? And we'll calculate the total cost, and now the minimum has decreased. The minimum has become 10. Pretty cool, right? And now we still don't know whether this is the optimal solution or not. So what we can do is we can go ahead and test out the index 2 as well. Right, we are now going to start the contiguous segment from 2. And so on and so forth, we can keep on doing, we can keep on increasing the starting position of the segment. And for every single starting position of the segment, we are going to calculate the time taken, the number of moves taken for every single person. We can sum them all up together and we'll be able to get to a solution. At the end of this iteration, as we have tested out every single index, whatever is the minimum, we'll return it as the answer. Alright, so let's go ahead and implement this. I've implemented this in Python 3. And by the way, one of the things that you have to do for this question is switch to Python 2.7 because there are some issues in Python 3. I am not sure what the exact issue is, but it looks to be an issue on the InterviewBit side. So we'll skip over that. Anyways, switch to Python 2.7 if you're using Python. All right, so first thing we'll do is set up a mod, which is one of the requirements of the question. And now what we'll do is we'll figure out the indices for every single cross. So we'll iterate over all of those characters in A, basically iterating over all the dots and the x's, and we'll ask the question, hey, is the current character you're looking at, is the current character in X? Because if that is, well, go ahead and save its index. So by the end of this iteration, this crosses will have all the indices of x's. And that's fine. All right, so this is the first step. Now what's the next step? Remember that when we were looking at the array, when we were looking at the case like this, we started off from index 0. So let's go ahead and force everyone to go to index 0. What we'll do is we'll go from we'll go for I comma cross and enumerate of crosses. We'll do cross minus I. This is going to save the number of moves required, assuming starting position of the segment is 0. Right? So feel free to pause here and understand what's going on. We're looking at the index of one cross and we're going to move it to another index I, which is going to be the appropriate index, assuming that the starting position of the segment is 0. And now we're going to go ahead and find the number of crosses, and we'll simply say this is one edge case. We can simply say that, you know what, if n equals to 0, if the number of crosses is 0, well, there are no people and the entire row is empty, just return early and return 0. Saying that we don't require any amount of cost moving a person here from here to there because there are no person at all. All right, cool. This is a simple test case. Now we'll go ahead and initialize the answer starting from infinity. Remember, this is the minimum possible answer that we want to get. So I'm going to initialize with the maximum possible value. And now I'm going to start from all of the segment stars in range of length of A. Basically, whenever I have this kind of, so in this case, we have an array of length 10th, I am going to assume that a starting segment can be from anywhere between 0 and 10. So this is what I've done. I'm going to iterate over every single possible start of the segment. For each of these segment starts, I'm going to keep a track of the total cost for each segment, which is going to start from 0. And now I'm going to say for cross and crosses, basically for every single moves required. So this is the number of moves. Now crosses stores the number of moves. For every single one of these crosses, figure out the difference between this and the start of the segment. So this will give you the answer for the current configuration. And now we'll do total plus equals to this value and total mod equals to. So basically, this is like one of the extra constraints in the questions is the value can be very large. We have to return minimum value mod, what is this? I think it's 10 to the power 8 plus 3. All right, anyways. So this is like an implementation level detail. That's why I did not mention in the problem setup that I had. Anyways, once we have this total, what we can do is simply assign answer as the minimum value of the answer and the total mod with the mod. All right, so as we go ahead and iterate through the segment starting points, and as we go ahead and iterate through every single one of these crosses, we will be able to get an answer. So let's go ahead and quickly test this out. All right, looks to be correct. And we can go ahead and submit this. So you can see that this says test case easy success, but this will fail for hard test cases. And that's because of this loops over here. You see, this loop takes order of n time to run. And that's because we are iterating for every single possible segment start. Now this takes order of n, where n is the length of the array, which is the number of seats in the row. For every single one of those, I also have another order of n operation inside of it, where I'm saying for every single cross in crosses, do something. And now the number of crosses in a row can be order of n at maximum, right? If you have 10 people in the row, you can also have a worst case where all of these seats are filled. So this will just be a lot of pain to do, and this is order of n nested inside of another order of n, giving the total time complexity as order of n square. And you can see that the test case hard failed because the time limit exceeded. All right, so how do we start to think about optimizing this problem? I mean, this is already a pretty complicated problem, but now we're asked to optimize this. All right, let's go ahead and take a fresh start. Let's say that this is the configuration we have. This is the test case we have. Now, if we look at it, can we not say that, okay, assume 1, 4, 7, and 8 are people standing on these indices, right? So these are all of these people standing. Now let's say that the person 1 is standing alone, 4 is standing alone, but 7 and 8 are having an interesting conversation. Or maybe they're in a party and now they'll go ahead and invite person 1 and 4 to join the party. Now, where do you think both of these should land up? Like they want to all meet up together. right? That's the goal of the problem. We have to group together these people. So since 7 and 8 are already at their locations, they're going to go ahead and call 4 and 1 to come to their side, right? So this is one way we can think about it. The answer is hidden in clusters of people, right? So maybe if there is a very large cluster somewhere in the middle, then that might attract all of these people, and that might minimize the number of moves we take. So this is just a heuristic. And whenever we have heuristics like these, whenever you have ideas of how the solution might proceed, go ahead and do your best to disprove it. Instead of proving it, try to disprove it. And if you can find a test case where you can disprove it, well, you can go ahead and build your intuitions and observations more. So let's go ahead and take a look at another test case. This is a little bit more complicated, but it'll do the job. So now, if you look at it, there are like 3 different total clusters of people. There are 2 clusters in the very beginning, 2 towards the middle, and 3 towards the end, right? So what now? Well, since we said that maybe the biggest cluster is going to attract the most people, so let's assume that's the case. Let's assume 10, 11, 12 do not move, but they're going to invite everyone else. So 4 and 5 are going to move to 8 and 9. This is going to take a cost of 4 and 4 respectively. Similarly, we are going to call 0 and 1 to 6 and 7, right? So this will take a cost of 6 and 6, giving us a total cost of 20. Now in this case, you can see that all of them are grouped together neatly towards the end of the array. And maybe that is the answer we are looking for, right? Maybe 20 is the answer we're looking for. But now if we use the brute force solution to verify it, we'll find that the test case that actually satisfies the condition is this one. The configuration which satisfies this condition is this one, where we have the starting segment index as 2. And you can see that the score we get is 2 plus 2 for the first 2 guys, 0 plus 0 for the middle 2 guys. The middle 2 guys don't move, and the last 3 guys move and come towards this place. Now, what does this hint you at? It looks like everyone has come towards the middle of the array, right? It looks like everyone has come together with 4 and 5. Although the biggest cluster was 10, 11, 12, these 4 and 5 guys somehow attracted everyone else. So maybe it's the point of middle, which is the more interesting observation we can get. Maybe we have to think about it from a middle point of view. But now the question is, how do we exactly define a middle? At this point, I want you to pause and figure out what a measure of the middle could be. I know all of this has been pretty weird up till now, it's pretty new stuff, but feel free to pause at this point and try to figure out a solution. Because if you can do it, trust me, this is one of those kind of questions for which the solution you will never forget. You will never forget if you can figure this out on your own. Alright, pause right now if you want to try this out. Alright, so if you go back to school level mathematics, one of our chapters we are taught is statistics. And when it comes to statistics, there are 3 different very common basic ways of getting to know our dataset. There are 3 different measures that we use very commonly: mean, median, and mode. Now mode, as we already proved, is not going to give us a solution. We're not looking at the biggest cluster because 10, 11, 12 obviously move towards the middle. So mode is out of the picture. What about mean and median? Well, let's go ahead and assume that mean is going to give us the answer. So what we'll do is we'll take all of these indices of the people, sum them all up together and divide it correctly. So we'll have a total of 43 divided by the 7 people that are there. We have 43 as a total divided by 7 people that are there. And so the mean comes out to 6. Now what this means is, the mean means that 6 is the middle point of the array, which means that since there are 7 total people, there should be 3 people on the right of 6 and 3 people to the left of 6. However, it looks like 6 is not the right answer. 5 is. 5 is more middle than 6 somehow. So clearly mean is not the correct way to look at it. What about median instead? If we look at median, we get 0, 1, 4, 5, 10, 11, 12. And again, the middle element in this case is what? The middle element is 5. And 5 exactly matches with the optimal solution. It perfectly matches with the optimal solution. And so it looks like we are looking at median as the perfect position for these segments. So median is going to define us the answer. So let's go ahead and write down that instead of going for that large order of n segment start loop, what we're going to do is we're going to do something very, very simple. We're going to say that the segment start is nothing but the median of the array. Now, what array we are looking at? We're looking at the crosses array, and we'll figure out the n by 2 element. We're looking at the middle element. We're looking at the median. All right, so that is all I've done. That is all the change I've made. Let's go ahead and test this out once, and we'll go ahead and submit this. All right, so this works out. Anyways, I know this was a little bit complicated to figure out the median and the mean thing, but now that you know about the median thing, keep it in mind for future reference, because there are many other questions, especially the tricky ones like these, which require both knowledge of mean and median. So keep mean and median in mind, test them both out in given a test case, and see which one works out, which one does not. And that'll give you a better way to approach a problem and optimize the solution. This was a long video, and yeah, the visuals took a long time for me to make and create. So if you like it, give it a thumbs up. Let me know in the comment section down below. Gives me valuable feedback to work upon later on. And yeah, this is it for the solution to the problem seeds. And as always, thank you so much for watching.